Hi everyone! In this video, I'm going to talk about interface and polymorphism. I will start by creating classes that don't share an interface and show how client code has to deal with these concrete classes. After that, I'll introduce an interface that allows these related classes to share a common type and how it can benefit client code through polymorphisms and loosely coupled design. Let's create a class circle and store its radius as a private field. This class provides a constructor for client code to create a circle object with a specific radius. It also provides methods that return the radius, area, and circumference of the circle. The class circle overrides the toString method so that it returns meaningful information about a circle object. Let's create another class, rectangle, with two private fields to store its width and height. Similar to the class circle, rectangle has a constructor that takes two double values representing the width and height of a rectangle object. This class also implements some public methods that return the width, height, area, and perimeter of a rectangle object and overrides the toString method. Note that circle and rectangle are somewhat related, that is, they represent closed shape, but some of their method names are inconsistent. For example, circle has methods named getArea and getCircumference, while rectangle calls those methods area and perimeter. Such inconsistencies are not uncommon because different programmers may be working on related classes in parallel without having consistent naming rules. Now that circle and rectangle are ready, let's write a client program that uses these classes. This program creates a circle and a rectangle object with a specific size, and then prints the object's information and its area and perimeter. The client code knows that it interacts with circle and rectangle objects and that each object has different method names for returning its area and perimeter. While the interaction between the client program and circle and rectangle objects seem harmless, in object-oriented programming, there is a design principle called loose coupling. In a loosely coupled design, different objects can interact with each other without knowing much about the other parties. Less is more in OOP. The less an object knows about another object, the better. How can we decouple the client program from the concrete classes that represent circles and rectangles? Before I introduce an interface as a way to decouple between the client code and our classes, let's create a utility class shapes with a static method that creates and returns a list of random shapes. What should be the return type of this method? If we put a list of circle, the function can return only a list of circle objects, but not rectangles. If we specify a list of rectangle, it cannot include circle objects in the list. How about a list of objects? It's true that all Java classes, including our class circle and rectangle, have the class object as their superclass. So if we want our list to include both circle and rectangle objects, we can use a list of objects as the return type of the getRandomShapes function. Now let's see how such a function can be implemented. First, we create a list of objects to store a collection of random shapes. We use the class random available in the Java library to generate random integers. In this example, we want to produce a number between 1 and 10 inclusive as the number of shapes in the list. We then generate another random integer to decide whether to add a circle object or a rectangle object. If the number is even, we add a circle. Otherwise, we put a rectangle to the list. At the end of this method, we return the list of objects. To demonstrate how these classes work together, I'm going to create another client program. This program uses the utility class shapes to get a list of random objects. Then it constructs a loop to go through each item on the list. If the element is an instance of circle, the program typecasts it into circle and calls the corresponding methods to get the circle's area and circumference. Else, it checks if the item is of type rectangle and does the same thing. Typecasting object into circle or rectangle is required because the class object doesn't have methods that return the area and perimeter of a circle or rectangle object. Despite the cumbersome if-else statements to check each item's type, the client program works as expected and prints the collection of random shapes it receives. Let me refactor this code a bit by creating two helper methods to print a circle or rectangle object. Since these methods are to help the main function, I'm declaring them as private. It means that they are only accessible within the another client class. Let's run this program to make sure it still works. As you can see, the program works correctly, even though it contains cumbersome if-else statements and two similar helper methods. Having two separate helper functions, one for printing circle and one for printing rectangle, is necessary because these objects don't have a shared interface. We have to deal with the concrete types to print their area and perimeter, resulting in similar and somewhat duplicated statements. Back to an earlier question, how can we redesign these classes to be loosely coupled? Can we remove the cumbersome if-else statements in the client program? The answer is yes. We can use an interface to achieve loose coupling and use polymorphism to remove the if-else block in the client program. An interface specifies the behavior of an object without worrying about its implementation. What can an object do? By default, all methods in an interface are public, so we don't have to put the public keyword when declaring them. The shape interface states that every shape object must know how to compute its area and perimeter. Since different shapes have different formulas, the shape interface lets the concrete classes implement these formulas themselves. Circle is a shape, so is rectangle. Its type has an area and perimeter, so it makes sense for these classes to implement the shape interface. When we change the class circle to implement the shape interface, IntelliJ highlights an error message that circle must be declared abstract or implement all methods defined in the shape interface. Currently, circle has these methods but uses different names. We can fix this error by renaming getArea and getCircumference to area and perimeter. I'm using the refactoring feature available in IntelliJ to rename these methods. The refactoring process automatically changes the relevant method calls in the client program too. Let's do the same for the class rectangle. Since this class already uses the same method names defined in the shape interface, there are no further changes we need to do. After both circle and rectangle implement the shape interface, the statements to print the area and perimeter of a circle or rectangle become consistent. Furthermore, these classes now share the same type, shape. Let's write a more generic print function that takes a shape object and prints its area and perimeter. This function doesn't need to know whether the given shape is a circle or rectangle. As long as it's a shape, it knows how to calculate its area and perimeter. Recall that less is more in object-oriented programming. In this case, the print shape function knows less about the given object. It knows that the argument is a kind of shape, but doesn't know if it's a circle or rectangle. In other words, the function is loosely coupled from its argument. Before I show the benefits of interface and polymorphism, let's change the return type in the getRandomShapes method. Rather than returning a list of objects, we can change that the method returns a list of shapes. We also need to change a few statements in the client program. In the first version, the client program needed to check whether an item on the list is of type circle or rectangle, as they didn't share a superclass or supertype. After we modified the classes to implement the shape interface, we can rely on polymorphism to get the correct behavior of each object type. We don't have to worry whether an item is a circle or rectangle. What's important is each item must be of type shape, and each shape object knows how to calculate its area and perimeter. If the shape object is a circle, it will behave like a circle. If it's a rectangle, it will behave like a rectangle. The printShape method doesn't need to know the exact type of the given argument. The same statements can produce different behaviors depending on the concrete class of the object. This is polymorphism. So we can remove the cumbersome if-else statements as well as the printCircle and printRectangle functions. We can simply use printShape to print the area and perimeter of any shape objects. Now the client code becomes more straightforward and concise. We also end up with a loosely coupled design between the client program and concrete classes of circle and rectangle. Loose coupling is desirable in software design. Suppose we need to introduce another shape class, triangle. We can create a class and make it implement the shape interface. I'm not going to show the full implementation of this class, but you can look up the formulas to compute the area and perimeter of a triangle if you want to complete it. In the utility class, you can also change the code to include triangles. Now, when a client program requests a random collection of shape objects, the list may contain an additional type of triangle, which didn't exist before. However, since the client program is loosely coupled from the concrete classes and uses polymorphisms, we don't need to modify it to make it work with the new triangle object. That's the beauty of loose coupling, interface, and polymorphism. In summary, this video illustrates how to create and use an interface to achieve loose coupling and polymorphism. Less is more in OOP. The less interacting objects know about each other, the better. In this example, the client program doesn't need to know the exact type of elements on a list of shapes. Whether an item is a circle, rectangle, or triangle is not a concern of the client code. As long as they implement the shape interface, the client code will be able to interact with them. When a new kind of shape is introduced, the client code doesn't need any modifications to interact with the new type.